Alright, ladies and gentlemen, I'm going to go ahead. We're starting a new unit. It is Unit 6, Connect Area and Multiplication. You're on page 199. But for this lesson, I'm going to go ahead and tear this page out first. So when you tear this page out first, because I don't want the book around while I'm doing this, I want you to make sure to write your name. And please don't copy down what I wrote on name. Oh my, look how I'm going to have to adjust the coloring on that. Let's see. Just the brightness. That's a little bit better, but okay. So I want you to put your name on here in case this paper gets lost, okay? So we're going to start a new unit and we're going to be connecting area and multiplication. So how do I find the area? Hi, I'm Sam. I want to be an architectural drafter. This is what you draw plans with. When I design a new space, I need to know the amount of materials needed to complete the project. I can multiply the lengths times the width to find the room of the area. Okay, so if you're planning on working in construction or design, or there's a lot of stuff, guys. Anything that really goes with construction, you have to know how to find the area and the volume. But we're not getting to volume yet. So if you flip this back on the back, you're going to need some of these. You can use the ones for the base 10 blocks if you have them. So these are what you're going to have, okay? So it's showing you, look at the rectangles, and what do you notice? So there are 6 cubes here. There's hair. So there's 6 cubes, and that makes a rectangle, right? Well, if I turn that, that 6 stays the same, but it still makes that rectangle. All right. If I do this, it still makes a rectangle, and I can twist it and do this and still make a rectangle, right? Okay. So that's part A, seeing that 6 can make all these different rectangles. Can it make any other rectangle? Well, if I put 4 here and 2 on top, does that make a rectangle? It does not. So if I do this, it's not going to make a rectangle, is it? And I've got to use 6. That's only using 4. So using a rectangle is very important. So how many square tiles between 10 and 15 will make the most rectangles? Use the square tiles to make all of the possible rectangles for each number. Use the table to record your results. So this is a lot like scientists and gathering data and stuff like that, but we're gathering data from math. So you need 10 tiles, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 tiles. How many rectangles can you make? Well, so this is the time that you get to play around with it. So if I do a rectangle like this, I can have a 5 times 2, can't I? 5 in 2 rows, or I can flip it and make a rectangle this way. So there's 2 different ways. But if I take this and put it over here, that's not a rectangle, is it? No. And if I put this one right here, that's not a rectangle because this one here is off. But I can make that straight line, can't I? I can make a straight line rectangle like that. And I can twist it, make it like this. So this is me thinking. You're going to have to think too. If you need to pause the video, then you pause the video. So there's one. I can't move that. I can't move these because that's not going to make it a rectangle. But I'm back to 2 rows again of 5, and I can twist it both ways. So I can only make 4 different rectangles because if I twist it up or down, just like they did up here, see how they twisted their 6 sideways and stuff? So I could do a straight line, or I can do 2 rows. Dimensions of each rectangle would be 2 times 5 or 1 times 10, right? Now it's wanting us to add 11. Uh-oh. Uh-oh. This is going to be bad. Let's see. If I do 3, then I still only have 2. That's not going to work. And I can't do 2 rows. Can I? No. I can't do that. Okay, you might find other ones, but Miss Haycraft is only finding 1, or actually 2, because the only thing that I see that I can do, and you, like I said, you might find more, because this is discovery. Alright? I can only find this way, and then I can turn it and make it go straight up and down, and that way. So I can only find 2, which would be, and we can flip these around. Remember commutative property? So 1 times 10 or 10 times 1. So I could flip this around too up here because I said 4. So it would be 5 times 2 and 10 times 1. So it could be this or 10 times 1. Okay, so I have 11 blocks. Now I'm going to add another one. Let's see. I'm just trying to make a rectangle. Oh, look at this. Aha! 4 and 3. I can twist it and do 3 and 4. So there's 1. I'm going to go ahead and write that down here. 3 times 4 and 4 times 3. Okay. I wonder if I can do rows of, I already did rows of 4, but I can't. Can I put these up here? And please, again, pause the video and see what you get. Oh, I think I got another one. That's a rectangle, and it's 2 rows of 6. So 2 times 6 and 6 times 2. And I can't forget that I can turn it this way. So that's the reason I do commutative property. But guys, I also can't forget that I can do that straight line, right? I can do that straight line to make that rectangle. It's really long, but it's still a rectangle. And so that's 1 times 12. And 12 times 1. Is there anything else? I don't think so. Because they said they had 5 up here. But if I put them in groups of 5 down here, then I got these 2, and then if I stick them on the end, then that's where I get back to my 6 times 2, and I can't put them down here. So I think that's all. So I can do 6 there. That's interesting. Look, you would think that since you had 11, you'd have more, but I have less. And when I got to 12, I've got more. I wonder what's going to happen when I get 13. Well, I can already see a problem. That's not going to work. I wonder if... No, that's not going to work. Well, sugary doodah. That one odd, he doesn't have a buddy and he's making me mad. Well, I hope you all can find something else, but all I can find is that one straight line again. That's all I can find is that one straight line again. So all I can find is 1 times 13. And 13 times 1, because there's 1 and 1 row of 13. So I only could find 2 on that one again. Look at that. 4, 2, 6, 2. I'm just wondering if there's not going to be an 8 here, because this went up by 2 when I added 2. But I'm not sure yet. So I've got 13 right now. I've got to add 1 more for 14. Alright, I've got to add 1 more for 14. Alright, so I know I can do 1 times 14 and 14 times 1. That's my first one that I know. let's see if I can break it in half, because it is an even number. Haha, looky there. I could break it in half, so I'll have 2 times 1, 2, 3, 4, 5, 6, 7. So 2 times 7, and then 7 times 2, because of commutative property. Alright, let's see if I can do 3 rows. Can I do 3 rows? I can't do 3 rows. Look. I need one more to do 3 rows. Sugary doodle. Alright, so can I do 4 rows though? No. Can't do 4 rows either. Can I do 5 rows? Nope. Can't do 5 rows either because I need another one. Well, this is interesting. It's my theory, my guess is incorrect. So I can't do 6 rows because I've got these 2 still. And I'm back to my 7. So therefore, I can only do 4. What? So 12 has more than 14, even though the number of tiles is less. Let's try 15. Alright, so we put one more in there. Now again, I want you to really try, because Miss Haycraft may be wrong on these. But remember, you have to make an even rectangle, and you have to have that number of tiles. So now I've got 15. So I already know I can do 1 times 15 and 15 times 1 because I can put it in that straight line. So I'll put it in that straight line. I know I've got this really long rectangle. And so how about if I cut that in half? Can I cut it in half and make a rectangle? Let's see. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15. I can't do 2s. Let's see if I can do a row of 3s. So I'll put that down there. Put that over there. And put these 2 down there. Aha, looky there. I can do rows of 3s. Oh my goodness, I hope I'm not getting sick. So I've got 1, 2, 3, 4, 5. So 5 times 1, 2, 3, 3. And so I can flip that around because I can rotate this rectangle and get it 3 times 5 also. Wonder if I can do a row of 4. Let's see. So there's 3 rows, so if I move this down here, that's a row of 4. So I can't do that because it's got a missing. How about, well, then I'm back to a row of 5, aren't I? Well, it's only had 4 there too. There's no pattern. You just have to solve for each one of them, isn't it? That's what you gotta do. Alright, so, very interesting. You know, I know it's not on this page, but I wonder if you had 20 tiles. I just wonder. You know, I wonder if that would make a difference. Why don't you try it and see? See how many you find. I'd be interested to see your papers when you turn them in on Friday. Remember, this paper is going to be stapled to your work plan. I really hope you got your tiles out and really thought and worked and moved it around, not just copied me, because this lesson is investigative. You know, you're trying to make sense and reason out of the numbers and moving them.